What's up everybody, Bryce Michael RC here, and I had at least one person ask about the brushless motors. I offered to show you guys how brushless motors work, and one person said they'd be interested in knowing, so I'm going to go ahead and make a video, at least so that one person or anybody else that stumbles over this video can learn something. You know, sometimes you just want to know the intricate parts of it and the internals and things like that. So before we get started, I'm going to show you a brushed motor here. This is a regular toy grade brushed motor. It's way different from a brushless motor. It's got the two cords here. When you buy these for like a quadcopter, they have clockwise and counterclockwise. You don't really need to get clockwise and counterclockwise because you can change the direction by just changing where you put the cords in and stuff. And when you're buying motors, any types of motors, I wouldn't worry about clockwise and counterclockwise unless it comes to the brushless motors. And you're getting the twist offs that go against the rotation of the props, so they stay on tighter. You don't necessarily have to, because you can get all the same and get the locking nuts. But if you're going to get these bullet ones, then you're going to want to know the clockwise and counterclockwise just for the thread, so it spins against the thread and tightens it rather than loosens it. When it comes to brushed motors, you don't really have to worry about anything like that. You can just get all four of the same ones and just switch the cords on the inside if you're doing soldering or anything like that. Some toy grade drones come with a hookup on the end. They got a real quick attach and unattach, and so you're going to want to get the clockwise and counterclockwise because the attachment's put on a certain way and it won't fit in the other way. You can always take that attachment off. Cut the attachments, twist the wires together, solder them, and things like that. So anyways, just wanted to show you a brushed motor real quick. They're a little bit more dangerous than the brushless motors. And they're a little less steady, and they don't have as much torque and thrust in them. So they're definitely a less advanced model of motor, but they're good for toy grade drones that only fly for about 6 minutes at a time. And here's the brushless motor here. You can see that's what we're going to be going off of. You may have looked inside of these and wondered, man, I wonder how this works. You know, this doesn't really touch anything. You can spin it, and you've got all those wires and all the different things on the inside. And then these three wires out here, why do they go where they go and things like that. Well, I'm going to explain it to you real quick, and it's very, very simple. Brushless motors are a real simple design. They're a better design of motor. They're a more stable flight, and they give you the best performance out of your drone when you're flying a quadcopter. So this is basically a real simple breakdown of it. You've got what's called your rotor here. But your rotor is what is on the outside that spins around those coils right there. So this right here would be the rotor. You've got your rotor, and then you've got the inside part, which has these ends here, and then they're wrapped in coil. And the coil is really what makes it work itself. You can see down here I've got it labeled A, B, and C. And then if you were to look over here, it would be A, B, and C. They attach to the coils on the other side as well, so that you can see this cord here is attached to that coil, so forth, and so on. Now, when you apply a DC current to this, DC current is a direct current, it acts like a magnet, causing a magnet to pull here. Now see, the reason why there's three wires, 1, 2, and 3, is because each wire is plugged into each one of these. So this is one wire, this is the second wire, this is the third wire. So that's how it goes. And so your wires are going to be coming in from the outside, 1, 2, and 3. One's going to plug into the first one, second one, and third one. Okay, and then you're going to have an ESC, or a control board, and your control board is going to tell it's going to power each one of these when it needs to be powered. It's going to decide when power needs to run through these, and then initially turning these into magnets. You can see right here on the rotor there's a north and a south. There's this is one magnet here with your north and your south. So you can see over here, this is a better picture of it. You've got the north here and the south here. So when current flows through this, say that north and south is here. So when current flows through this, it pulls that this way. And then it kicks on the next one, the next wire. So we're just going to say that this magnet here, this first one, is connected to this first wire here. Okay? So now this is moved over to here, and over to here. Now it sends a direct current to this one here, which causes this to turn into a magnet and this to stop being a magnet, which then takes that and pulls it here, and takes this off and pulls it to there. And then it does this, sends a direct current to this one, which turns this into a magnet, and then so forth and so on. And so as it spins, your ESC, your control board that has your 3 cords on it here, and then you've got your negative and your positive and your data cord. There you go. So now your flight control board is your gyro system is for one, say that you're in a hover. It's trying to keep itself steady, and it goes to the side. And so that's sending information to the data board, and then this is getting power directly from the power distribution board, and it all comes into here and then comes out, and it tells which one of these needs to be powered and how fast it needs to be powered. So it doesn't really give this a certain amount of charge. Each one of these gets the same amount of charge. It's just how fast it needs to get a charge, because it could be rotating it around so fast that it's just going, but then it slows down, as it needs to get into more of a hover or maybe a landing or something like that. It slows down the current that goes into it. So that's basically what the ESC is doing right there. Is it's basically just it's judging the gyro in the board, plus also your controls from it's taking your controls from your transmitter, going into the flight control board itself, and then it's calculating through this cord here and into the ESC where that motor needs to be to keep that steady, to keep it where it's at. If you push forward and you want your quadcopter to go forward a lot faster, and this is a back ESC instead of a front ESC, the front ESCs, the data is going to slow it down. The back ESCs, the data is going to speed it up. And it all just depends on, it's getting calculated into here, and it's telling it, this chord, then this chord, then this chord, this chord, this chord, this chord, this chord, and then faster. And the faster it goes, the more it spins, because this one's going to be, say it starts out right here, this one's going to be lit up first. It's going to pull it. It's going to keep it rotating. Now, I'm not very good at teaching this type of stuff. I'm hoping you guys can follow along and understand how I'm trying to explain this. Hopefully that helped you guys out. Maybe I can do another real quick. A really easy way to think of it. Right? And these stay steady the whole time. It's your outside rotor that constantly spins. And it's just your north and your south of your magnet that just, and now you've got your 3 cords that come in. This cord goes to these 2. This cord goes to these 2. And this cord goes to these 2. Like that. And so if it hit this, this would swing down, this would swing up, and then it would power the next one next, and your ESCs would keep it in a constant spin. Now, they've got programming in BL Heli Suite and other things where you can just set them up how you want to and reverse it. But that's the reason why, if you don't want to go into BL Heli Suite and set the reversed, what you can do is you can just take these chords and you can reverse any 2 chords, and it's automatically going to cause the spin to rotate a completely different direction. It's doing this from up here. It's still going 1, 2, 3, 1, 2, 3. So now it's going 1, 2, 3. Instead of 1, 2, 3, it's going 1, 2, 3. What you can do is you can set your currents up to give your brushless motors more torque. You can actually set your ESCs up to do, instead of 1 chord at a time, instead of calculating 1 chord at a time, you can get it to where it calculates 2 chords at a time, and it gives you more thrust and more torque. And it actually 2 coil sets at one time and only has 1 coil set that's not in a magnet. And so it actually pulls it harder. It's kind of like, the best way to explain the way that a brushless motor works is kind of like, I don't know, have you seen those dogs? You know, let's see if I can draw a dog. And now somebody has strapped this little thing on, and they've got a little bone on the end. Okay? And he's always chasing it. He never gets to it. Because this is, once it gets to that magnetic coil, it automatically charges the next magnetic coil. And so it keeps pulling it. It's never over the top of it. It just keeps pulling it. So as soon as this moves, this one's charged, and then it gets to here, and then this one charges. And it's constantly right out of its grasp. It never matches the magnets up, but it's constantly chasing it. And when you double magnetize them, and then it's going a lot faster, and it's doing 2 at a time, and your torque, your instant, you got a lot more thrust and a lot more torque, and you've got a faster quadcopter, a faster brushless motor, and he's running faster and faster and faster. And I'll say that he's got 1 bone, you get a little bit annoyed by. But now you add some bacon strips on top of that. That gives it a good little smell coming off of it. Now that dog's going out of his mind trying to get to that bone. And that's basically the same thing. This north and south part of the magnet want to get to that so bad that it's going faster and faster and faster and trying to get it to it. And your ESCs are just calculating when a power surge needs to be sent through each one of these 3 wires that goes into your 1, 2, and 3 brushless motor wires. And that's basically that. So sorry if you couldn't follow along, because I'm not that elegant of a speaker. But maybe some of you guys are a little bit more like me, and you're going to understand this a little bit better, because I talked in such layman terms, and you guys are going to get it a little bit better. I don't know. But anyways, hit that subscribe button, hit that thumbs up button. Hope you guys enjoyed it. If you would like another one of these little lessons on motors or any parts, if you would like more of a breakdown of an ESC, more of a breakdown of a flight control board, or if you would like more of a breakdown on the brushed motors, leave a comment and let me know, and I will try to delve into that as much as I possibly can. Just don't expect too much because, like I said, I'm not a teacher. Anyways, we'll see you guys later. Keep checking back. Have a good one.